How are you, my dear student? We will explain today compound interest as we stated in the previous lecture. We will go to today to 3.6. How many places? The factors in table 2 and table 3 in your book in compound interest chapter 3 are given to 10 decimal places, making them adequate for handling large sums of money. In the examples worked in the tables published by the financial publishing company, the complete factor is used and the answer is rounded to the cent. What's the meaning of rounded approximation? Rounded mean approximation. If a calculator is available, as it usually is in a business, this method is the sensible one to use in working a problem since it ensures maximum accuracy without any troublesome questions about the number of decimal places to use to get answers correct to the nearest sense. This is what I mean by rounding and approximation. Now you can go to example number 1 under 3.6. How many places in chapter 3 related to compound interest? This example related to find the compound amounts of $25, $2,500 and $2,500,000 invested at 6% converted quarterly. You must notice that 6% converted quarterly for 5 years. How we can solve this problem? We must go back to the compound interest formula. Compound interest formula you can find in your book in page 109. In page 109 you can find S equal B multiplied by 1 plus I to the power n. As we stated in the previous chapters, the sum of simple interest and the sum of bank discount in chapter 1 and chapter 2. Now we will compute. We are required to find the sum of compound interest as the sum of simple interest in chapter 1 and sum of bank discount in chapter 2. Now we are required to find the sum of compound interest in chapter 3. So we have three sums. Sum related to simple interest in chapter 1, sum related to bank discount in chapter 2, sum related to compound interest in chapter 3. So that our formula is equal P multiplied by 1 plus I to the power n. So that our present value, our B 25 multiplied by 1 plus I 6% converted quarterly. You must notice that very closely. 6% must be divided by 3 converted quarterly. Converted quarterly. You must notice that 6% converted quarterly, you must divide 6 by 4. You must notice that 6% must be divided by 4 because converted quarterly. 6% must be divided by 4 and 5 years must be multiplied by 4. Then after 6% divided by 4 and number of years divided by 4, number of years multiplied by 4 as we see in this slide, you can calculate your S, your sum, compound amount related to compound interest, so that you can find the first amount and also the second amount and also the third amount by an easiest way. There is no any problem now to compute S related to compound interest, which named compound amount. Now example number 2 related to 3.6, how many places in compound interest. A principal of $1,000 is deposited at 6% for 10 years. What will be the compound amount and the compound interest if the interest is computed annually, semi-annually, quarterly, and monthly? This is very important illustrative example. This is a very important illustrative example, and you must understand this example very closely. A principal of $1,000 is deposited at 6% for 10 years. There is no any problem. What will be the compound amount and the compound interest if the interest is computed annually, semi-annually, quarterly, and monthly? This is our solution. The required factors and the final result are summarized in the following chart. As the frequency of conversion is increased, interest is added to principal more often, more and more, so the depositor has a larger amount credited. Frequency of compounding annually, rate 6%, number of conversion periods 10 multiplied by 1. 10 multiplied by 1 must be equal 10. Amount of 1, compound amount, compound interest. Compound amount of 1 plus I to the power n, as we stated in the previous lecture, 1 plus I to the power n, called accumulation factor. Called accumulation factor, it's very important. Compound amount is, it's equal 1 plus I to the power n multiplied by b. Compound interest equal S minus b, the sum minus the principal, the sum minus the present value. Okay. What about semi-annually? Semi-annually, 6 must be divided by 2 equal 0.03, and the number of conversion periods 10 multiplied by 2 equal 20. You can also calculate your amount of 1 plus I to the power n and calculate the sum S equal B multiplied by 1 plus I to the power n, and you can calculate your S. Also, you can calculate your compound interest sum minus the present value or the principal. What about quarterly? 6% must be divided by 4. So that rate period I equal 6% divided by 4 equal 0.015. And the number of conversion periods in 10 years must multiplied by 4. 10 multiplied by 4 equal 40. Amount of 1 plus I to the power n, this is the amount of 1. Compound amount S equal P multiplied 1 plus I to the power n. You can calculate your S, and also you can calculate your compound interest S, the sum minus B is minus the present value or the principal. What about monthly? 6% monthly must be divided by 12. Must be divided by 12. 6% divided by 12 equal 0.005. And the number of conversion periods n 10 years must be multiplied by 10. 10 by 12 10 by 12 equal 120. You also calculate your amount of 1 plus I to the power n, and calculate your sum S equal B multiplied by 1 plus I to the power n, and also you can calculate your compound interest S minus B, the sum minus the principal. So that you must understand this very closely. This is maybe MCQ in your exam. If your percent annually 6 or any percent must be divided by 1, there is no any problem. Semi-annually you must divide your rate per period by 2. Quarterly you must divide your rate of per period by 4. Monthly you must divide your rate per period by 12. Annually divided by 1. Semi-annually divided by 2. Quarterly divided by 4. Monthly divided by 12. But what about the n, number of conversion period? Number of conversion period, if annually multiplied, not divided, multiplied by 1. Semi-annually must be multiplied by 2. Quarterly must be multiplied by 4. Monthly must be multiplied by 12. This is very important and you must understand very closely because it's very important in your exam. Example number 3, banks and other saving institutions offer certificate of deposit and other saving instruments that permit deferral of interest payment until the deposit matures or is redeemed. This practice makes possible the automatic reinvestment of interest at the rate paid on the original investment. This rate is usually higher than the rate paid by the institution on its passbook account. A person aged 60 bought $10,000 in a deferred account paying 8% converted quarterly. The account is to mature in 5 years. Find the amount at that time. You can go to the solution substituting B equal 10,000, I equal 0.02, N equal 20. In formula 9 we have B, this is the principal, this is the capital, the money at the investment period, 10,000. What about I? Your I, 8%. 8% converted quarterly. 8% converted quarterly must be divided by 4. So that the result of I equal 0.02, 2%. And what about N? In 5 years. In 5 years. You must notice that in 5 years. But converted quarterly must be multiplied by 4. So that N equal 20. In substitution, in your formula, S equal B multiplied by 1 plus I to the power N. B equal 10,000. 1 plus I 0.02, 2%. To the power N, N equal 5 years multiplied by 4 equal 20. So that you can calculate 14,859.47 cents. This is your calculation. This is your amount. This is your result by an easiest way. But you can understand very closely. This is 8% converted quarterly. I divided by 4 equal 2%, 0.02. In 5 years converted quarterly must be multiplied by 4, N equal 20. And you can make an easy substitution in your compound interest formula. S equal B multiplied by 1 plus I to the power N. Table 2 and Table 3 list compound interest factor for main rates. The financial compound interest and annuity table published by the financial publishing company gave many more about this idea, and this idea is very an easy idea. There is no any problem. Any set of tables, however, will be able to include only a limited number of values for rates. If you use a calculator with exponential capability, you can work with any rate. Thank you for every student and see you in the in the next lecture.